Hello everyone, my name is Rison. I'm a recent graduate of Advanced Master Program Designed by Data at École ParisTech. The title of the paper I am going to present is Assembly Aware Design and Construction of Interlocking Masonry Structures. It was completed under the supervision of Professor Olivier Baverel, Romain Mesnil, and Jean-François Caron while doing my internship in the Navier Lab. So for the context, the total cost of the material and labor for formwork often consumes up to 50% of the total construction cost. And notably, 2.14% of the construction industry's waste is formwork. The construction industry being one of the largest in the world economy with 10 trillion USD spent every year, the losses in time and resources are gigantic. To tackle these issues, we propose the study of topological interlocking geometries. It will help us to build without mortar, recycle, and rebuild structures whenever we want. Our main goal for this study is to be able to build a structure without any formwork. We want to design interlocking geometries that can be used with construction robots. We kept the geometries as simple as possible for the hassle-free construction. The study is limited to the use of one or minimum number of discrete elements while exploring different forms. The paper mainly explores two different categories. First part explores interlocking cubes and polycubes, while the second part focuses on the construction of structures using BURR puzzles. We started with the already known interlocking cubes. Here the animation shows how the assembly works. First, we build a pyramidal aggregation using only cubes as shown in the figure on the right. Then we try to approximate the interlocking cubes on various curved surfaces. Our intention was to make a roof structure such as a dome. While doing it, we observed that most of the elements have lost their planar properties, which eventually led us to the use of Mobius transformation. The easiest way to create a topologically interlocking dome with cubes or any other geometries for that matter, we suggest the use of Mobius transformation. This transformation helps us to retain the planarity of the given surfaces, and more importantly, it preserves the angles. That means a right angle will be preserved as right angle after the transformation. After that, we explored many different interlocking polycube geometries, out of which two different geometries are found more useful. The triphase extended geometry is a polycube, and the interlocking of this geometry is visually similar to that of interlocking cubes. The possible aggregations using these polycubes are planar and pyramidal. The major advantage of the pyramidal aggregation in terms of autonomous construction is it is easy to assemble, disassemble, and the elements are identical. The hex phase extended geometry is same as tri-blocks, but it has a double interlocking effects. The animation just showed how the assembly works. Later, we explored many possible aggregations using these mentioned geometries, and we managed to build a wall, floor, slab, and a roof, and other possible configurations, as explained in the figure. The last part of the paper explains the strategy to build a structure with only BURR puzzles. The animation just explained how a traditional interlocking BURR puzzle works. By taking inspirations from the interlocking BURR puzzles, we modified it to suit to our needs. We extended all the 6 pieces of the puzzle in 6 different directions and used it to make an interlocking structures. Here the video explains how we modified the traditional BURR puzzle. Here the video explains how an interlocking can be achieved using these puzzle blocks. The blue part shows the local interlocking effect. So the interlocking BURR puzzles can be used to make virtually any forms and shapes. It is moderately simple to make. It is also easy to assemble since every interlocking puzzle block has a locking key, and it might be suitable for robotic construction. As a conclusion, after exploring numerous polycubes and BURR puzzles, we managed to make a roof, floor, beams, domes, etc. With our BURR puzzles, we demonstrated that the construction of different forms was possible. Now we plan to further study the structural behavior of these aggregations. Thanks for listening.